Today we are installing a new pilot unit in our incubation area here at Drax. This pilot unit is focusing on next generation CCS technologies and is going to help us to remove the CO2 from our flue gas. BECCS is really important in tackling the climate crisis, mainly because of its ability to remove carbon dioxide from the atmosphere directly. Here at Drax we have the potential of removing up to 8 million tons per annum of CO2 from the atmosphere directly by 2030.
The name MOF is a bit confusing because it stands for Metal Organic Framework. It is essentially a highly porous material made up of metal ions and organic linkers. At the moment, we're at a turning point with MOFs because we can now manufacture them at scale, which means that we can start to use them in pilot scale settings or full scale settings. This trial that we're doing in the next few months is very exciting because it gives us a chance to show that MOFs perform in an industrial setting with actual flue gas rather than synthetic gas that we might make in a lab. We're hoping to scale up the technology and actually capture hundreds to thousands of kilos of CO2 per day after this trial.
There's really only one major technology that's in play today with regard to carbon capture, and that's with what we call amine scrubbing. Now, they work very effectively. Amines love to grab hold of carbon dioxide, but that's also its biggest downfall. In order to get that carbon dioxide released again, we actually have to inject a lot more energy into the process. And MOFs are much more efficient at doing that because it's more of a physical trapping. Think of them more like sponges or sieves, and so it's much easier for them to release that and therefore more energy efficient.
Working in such partnerships is very important because we're bringing together R&D expertise, but also industrial expertise together in order to tackle climate crisis as fast as possible. So this actually will also help the UK meet their climate targets.